So now we're going to talk about mixed numbers and improper fractions, okay? So these are things that we have seen in our lectures so far. We haven't talked about them explicitly yet, and you'll see what I'm talking about in a moment. Um, but we're going to see that they're important, and I need to at least let you guys know what they are right now for preparation for later. Now, in this section, in this lecture, we're also going to talk about how we convert from mixed numbers to impropers. But in future lectures, we're going to show how to go from impropers to mixed numbers. Okay. But okay, so now let's talk about what these mean. So what are mixed numbers and improper fractions? Okay. Mixed numbers and improper fractions are used to represent quantities that are greater than a whole. Okay. So for example, an improper fraction is a fraction whose numerator is greater than its denominator. So for example, if I have the fraction 3/2, this is an improper fraction. And if we think back to what we meant by a fraction, we know that we would divide the whole into the number of pieces specified with the denominator, and the numerator would tell us how many pieces would be represented by the fraction. In this case, we therefore see that a whole would be sliced into two pieces, and I'm talking about, and this fraction would represent three of those pieces. So that would mean if I had a whole here and I sliced it into two pieces, and let's say I had a whole here and I also sliced it into two pieces, this fraction would represent these two pieces plus one of these two pieces. So you see this fraction 3/2 represents more than a whole. The other common way of describing more than a whole is with a mixed number. And a mixed number is a number with a whole part and a fractional part. So let me show that to you here. Let's say I had 3 and 1/5, okay? This would be your whole part, okay? So I have 3 wholes, and this is your fractional part, okay? So I'll just put it frac part, because I can't write fraction there because like it's too little space. So this would be how many wholes, and this is how many of the remaining wholes. So let's think we're talking about brownies. Okay. I have one tray of brownies complete. Okay, let's say these are like cut into pieces like that, They're super delicious. They're made with my special recipe, which is, the most unbelievably decadent and luxurious chocolate brownies that have ever been made by humanity. Okay, this is my second tray of brownies. Okay, this is my third tray of brownies. It's also complete. Okay, and then I have 1/5 of a tray of brownies. So let's say I'm gonna have to draw it small because it won't fit on my board. Well, I'll draw it here. Okay, so it's gonna take up the room of my other example. But let's say I slice this up like this. Okay. And then, but instead of the whole tray of brownies, it's just this piece here, because you can see that the rest of the so this is 1/5 of the tray. The tray has been sliced into 1, 2, 3, 4, 5 holes, and only one piece is filled. So 3 and 1/5 also represents more than a whole. This is how many complete, and then the fractional part is how much more. Okay. Okay. So now let me show you basically the one technique that in this section we have learned how to do, and that is how to rewrite a mixed number as an improper fraction. So, and the key fact I want you to take away from this, continuing this example from the bottom here, is that whenever you have a mixed number, like let's say 3 and 1/5, what that actually means, it's identical to 3 plus 1/5. And we learned in our lecture so far that this is an addition that we can perform, okay? Because of course we would change this into a fraction by setting it as 3/1 and then plus 1/5. And then we would be able to rewrite 3/1 we would be able to find an equivalent fraction to 3/1 by finding a fraction with the denominator of 5 that is equivalent to 3. So what I'm going to do is I'm going to write that as 3/1 times some fraction that is yet unknown to us plus 1/5, okay? Okay, that's perfect. And so we know that if we ask, okay, what times 1 gives me 5? I know that 5 does. So I multiply the top and bottom by 5 as we learned before. And I can get 1 times 5 is 5 on the denominator. 3 times 5 is 15 in the numerator. And then plus 1/5. We know now they have the same denominator. So I can add the numerators. 15 plus 1 is 16. And we keep the denominator. And so what we have just seen here, to summarize this, is that I have 3 and 1/5 represents the same amount as 16/5. Okay? So we know if we were looking at this in terms of, if we were looking at this example in terms of fifths, this would be 5/5 being a whole, 5/5, 10/5, 15/5, and the 16/5. So we see, I'm sorry about that, excuse me. So we see that this is in fact true, and this corresponds to exactly what we've learned so far. Okay, so we know that. So we now know what a mixed number is. It's a whole part and a fractional part. It means the same as if you have the whole part plus the fractional part. Of course, that's what it means. And using our previous techniques, we're able to express this mixed number as an improper fraction. Okay. And so now we know how to go from mixed numbers to improper fractions. And so what we've also seen here is that improper fractions basically are all we need to represent quantities. Bigger than 1, they're improper. Less than 1, they're mixed numbers. Okay, and less than 1, they're proper fractions. Greater than 1, greater than a whole, it's improper fractions. But of course, the mixed numbers are nice because they're easier to understand. Oh, I have 3 and a little more. Okay. Okay. So in future lectures, we're going to learn how to go from improper fractions to mixed numbers, because of course that's going to be useful, and we'll do some more work with these mixed numbers and improper fractions. Until then, be well, and I'll see you again soon. Thank you so much.